Welcome, my fellow assassins, to this programming tutorial where today we are going to look at how you properly resize an array in C and C++. So first off, I have two files here. I have this resize.c file, and I have a make file which will just compile the program for us. So in resize.c, I have a couple helper functions here that'll help us for this program. Init array just initializes the array with random values. Print array just prints out the array, and then realloc debug is kind of the secret sauce to this program. Not really, but essentially all it'll allow us to do is force a failure of realloc by just returning null. So in cases where realloc fails, it doesn't change the pointer that you pass in and will just return null. So this will essentially simulate that happening with realloc failing. And that's essentially what this ternary operator is saying here. If fail, this Boolean value we pass in. If fail is equal to true, we return null. Otherwise, if fail is false, we return the value of realloc. Now, it is technically possible that realloc could return null anyway, but it is pretty unlikely, at least in our use case here. And then here we just have a simple command line parser, which will just take the values that we pass in and set that to size and new size respectively. So let's get into the code here. So first, let us create our array. We'll do int array is equal to malloc with the size times the size of an integer, and that will allocate enough space for our array of size, whatever that ends up being. And then what we can do is, because we're going to be good programmers, let's check if array is equal to null. That means we had an error, so we can do printf standard error malloc failed, just like that. And then we can come down here and then return exit failure, just like that. So if we get past this point, we know that malloc succeeded, so we can initialize the array and give it the size, and then we can print it out as well, just like that. And then because we're going to be good programmers, let's free our memory at the end. So free array, just like that. And then if we come down here and run make, we don't get any errors, so that's good. Resize, we'll give it an initial size of, say, 3, and then a new size of 7. New size won't actually do anything right now, but we hit enter, and there we see we have our array of 3 elements, and they are initialized to random values. So that's good. Now we want to get into resizing. So just briefly, why you would want to resize an array. So for instance, let's say we were expecting 3 elements from an API call, but we ended up getting 7. In order to account for those additional 4 elements, we'll need to resize our array. And in order to do that, we'll call realloc in order to reallocate and resize the array. Now, I'm going to show you 2 ways to do it. The first way is the incorrect way, as we'll see shortly. And then the second is the correct way to do it. So getting into the incorrect way here, first, we will do array is equal to realloc. We'll use our realloc debug so we can force a failure. We'll give it the array that we're wanting to resize and the new size, which is new size times the size of an integer. And then, of course, we want this to succeed, so we don't want fail to be true, so we'll set that to false. And then again, because we're going to be good programmers, we can actually just copy this code up here and paste it in there. And this is not malloc anymore. This is realloc debug. And this is new size. And here I'm just going to allocate the new memory that we just got back from realloc. So in order to do that, I can do the address of the size, which will get the first element from realloc debug, and then give it the delta between new size and size. So that will be new size minus size. And Get rid of that typo there. And if you want me to kind of explain why this works, I can go into another episode on how pointers work in C. So if you're interested in that, leave a comment down below and I will address that. So this should work. So let's run make again. No errors, that's good. And let's rerun it. And here we can see, so those first 3 elements are the same, and then we only initialize the last 4 here, and everything looks like it's working good. And if we run it through Valgrind here, what we'll see is everything is working fine. We don't have any memory leaks or memory errors or anything like that. So why is this way of doing it incorrect? So the reason why this is incorrect is if realloc fails, the pointer you give it is unchanged. And it instead just returns null. So what can happen is if you don't have another pointer pointing to the same memory address as the pointer you pass in theory, by setting this equal to null, you are losing the pointer to the memory address of that allocated memory, so you will no longer be able to free that memory, thus causing a memory leak. And to see that in action, we can force a failure here by setting this equal to true, recompiling and rerunning through Valgrind, and what we'll see is we do in fact have a memory leak here. So, like I said, the reason for this memory leak is because we're passing in a pointer to a address that was allocated from malloc, so it has memory allocated to it, but then we are setting that pointer equal to a different memory address, in this case being null, and no longer having access to that pointer to the allocated memory, and thus we leak memory. And even if we come in here and try to free the array, this isn't actually going to do anything because we're confirming that it's equal to null and you can't free null. But just to prove that point, if we go ahead and recompile this and rerun it, we'll see we still have that memory leak. So how do we actually fix this? So the fix for this is just to create a temporary value. So we can create a new pointer, we'll call it int temp, and we'll set that equal to the return value of our realloc debug. We'll change this to temp. And then afterwards, what we need to do is we need to set our array equal to temp. And the reason for this is if realloc succeeds, it will essentially return the address of the newly allocated space and will free this old memory here. So if you try to access the array after you call realloc and you don't set your array equal to the new address, you're going to run into some undefined behavior. So that's why we have to set it equal after here. But because we're setting our realloc debug equal to a temporary value, this will still give us access to our allocated array so we can actually free it if we run into an error. And if we can see that if we run make and then we run resize, actually give it the proper numbers here, and we'll run it actually through Valgrind. There we go. So here we can see we no longer have that memory leak anymore because we're properly assigning the memory address here. We're not overwriting our original array, and we still can be able to free it. So if we reset this back to false, and we run make again, and we run the resize, here we can see everything is just like we would expect we saw the first time, and we don't have any memory leaks. Everything looks all good. And yeah, that is how you resize an array in C and C++. Hopefully you learned something from this video. If you did, be sure to leave a like and subscribe. And with that, thank you all for watching, and I will see you in the next episode.